What's up, everybody? I had just recorded the solutions for quiz 13, but unfortunately the microphone was turned off, so I have to do this again. So let's go through it one more time. Hopefully this time everything will work fine. Let's look at problem 1. Right, this is a true or false problem, and I'm asking you whether the following statement, right, this computation of the integral from 0 to pi of secant squared is true. Now, secant is 1 over cosine, so basically all I'm doing is I'm integrating 1 over cosine squared between 0 and pi, and we know that cosine is 0 at pi over 2, therefore 1 over cosine has a vertical asymptote, right, a discontinuity at pi over 2, and therefore the fundamental theorem of calculus does not apply, which means this computation is incorrect, right? This is a false statement, so the answer is B. Now for problem 2, what we have is a Riemann sum here, right? And let me just go ahead and erase this little guy here. I made some notes earlier. It's a limit over Riemann sum, and the question is, which integral does this correspond to? And I'm giving 5 choices here. Now obviously you can see the answer, but let me tell you how I got that, right? I rewrote the sum by isolating this. Instead of writing it as I over n, I wrote it as 1 over n, and that became my delta x, and I moved this I together with the other I squares, give me an I cubed divided by n cubed, which came from this denominator right here. And so all I'm looking at is the sum 1 over n times I over n quantity cubed, and taking the limit of that, right? Now, the standard form of a Riemann sum is you have f of starting point of the integral, right, the lower bound, plus I delta x times delta x. So this would be the height of a rectangle, this would be the width, and then what you're doing here is you recognize, okay, this is the delta x, this is the function, so f of x is x cubed, therefore what I'm doing is the integral from 0, because the starting point here, I'm not adding anything, so it's 0 plus I times the delta x, to 1, because the length of my interval is 1, that's what the numerator of the delta x tells you, of the function x cubed dx. So the correct choice here is C, integral 0 to 1 x cubed. For the third problem on this quiz, now we're looking at a piecewise function, and we're asked to compute the integral from -2 to 2 of this particular function. Now if I go ahead and draw the graph of this, from -2 to 0, what I have is basically this line, right? So I'm looking at the area of a triangle, and from 0 to 2, what I have is a semicircle, right? The equation y equals square root 4 minus x squared determines the top semicircle here, and because I'm only looking at 0 and 2, I'm looking at a quarter of a circle. So we compute the area of each. The area of the triangle is base times height over 2, therefore its area is 2. For the circle, okay, if I had the full circle, that would be a circle of radius 2, so the area would be 4 pi, right? You have pi r squared, so 2 squared 4. But I'm only looking at a quarter of that, so I only take an area of pi here. Therefore, the total area is 2 plus pi, which is choice D here. Now, for the third problem, all this is asking you to compute the integral here, and that's the integral from 1 to e of 1 over x dx. So the antiderivative of 1 over x, that's natural log, and I'm evaluating that between 1 and e. So I'm taking ln e minus ln 1, that's 1 minus 0, which is just 1. So that's it for this quiz.